Okay, question number 1. F of x is equal 1 over x. So we need to find domain and we need to find range. So for domain, the domain is representing value of x, right? For x, we need to watch out so denominator cannot be equal 0, which means in this case, x cannot be equal 0, right? So if we cannot be equal 0, then the domain is going to be from negative infinity to 0. And from 0 to positive infinity. Okay, now regarding range, let me draw this graph. Here is one, here is, I'm just sketching, okay, how it looks like. All right, so as you can see, x is running here. We have it negative infinity x, right, in negative area, and positive infinity, right? So it's growing from negative infinity all the way to positive infinity. With the difference, it breaks into 0. It cannot be 0 because the graph never ran through this vertical asymptote with this asymptote. This is x is equal 0. Okay, and the same, let's see about y. What's going to be about y? We don't have point in the y, correct? In the x, y is equal 0. Our y is equal 0. It's right here also. And x is 0 and y is 0. And we don't have any point here because it's broken at point 0, right? Therefore, it's running from negative infinity to positive infinity with the difference that cannot be equal 0. Therefore, it's going to be the same way. Range is going to be from negative infinity. So from negative infinity to 0 and 0 to positive infinity. Okay? Question number 2. So write down domain for f of x is equal 1 over x squared. Okay, so in this case, again, domain, x cannot be equal 0, yes? So again, domain is going to be negative infinity to 0 and from 0 to positive infinity, and range. So to understand range, when it's x squared, that means x is positive, x is negative, y is going to be positive anyway, right? Because we have x squared, which means this part goes like this, but this one, this part in the first quadrant, it's going to flip. It's going to flip and come this way. Okay, it's not crossing, it cannot cross. So what do we have here? The thing is, we don't have negative y here. All our y is moving from 0, but it doesn't touch 0, obviously, and all the way to infinity, which means it's going to be parentheses. With parentheses, we show that there is no, the 0 is not included. It's not touching. From 0 to infinity. Question number 3. F of x is equal 1 over x squared. What do we need to do here? Identify if the function is odd or even and find what's the symmetry of this graph. So first of all, how are we going to identify it's odd or even? So if the power of variable, in this case it's x. If it's even, then the degree is even, then the graph is even, which is in our case is even. If the degree of variable would be odd, then the graph would be odd. Okay, and next B, so we have graph even. And what 1 over x squared, here we have, it's 1 over x squared. Is it symmetric to x or y? Of course it's symmetric to x. I mean symmetric to y, right? Here it is. This is our y. So the graph of the function is symmetric with respect to the y-axis, or across the y. It's symmetric. So we put symmetric to y. Okay. Question number 4. Now for question number 4, we need to identify same thing regarding f of x equal 1 of x. Okay, so is this function odd or even? Look here, degree here is 1, yes? That means it's gonna be odd. And the graph is symmetric to where? Here is our 1 over x. The graph is symmetric to its origin, right? Right here, origin. Correct? Therefore, number B, symmetric to origin. Question number 5. So, let's assume when it's a 1 over x, we have the graph 1 over x. And based on domain, the domain looks like negative infinity to negative 4 and negative 4 to positive infinity. So what does that mean? Originally the graph that we have, 1 over x, it's like this, right? And that was to 0, in negative infinity to 0, and 0 to positive infinity. Now since domain goes to negative 4, then our new graph, it's gonna look like this is, let's say, my negative 4. Yes? So the graph is gonna go like this. Because it's a breaking point is 4 instead of 0. Which means this 0, x is equal 0, this one, is moving to here. Shifting, instead of 0, we get negative 4, so it's shifting here. Okay? So let me... So here we have x is equal negative 4. Okay, so since x is equal negative 4, that's our asymptote. That means here our graph, this would be x plus 4. Why? Because if I put down x plus 4 cannot be equal 0, so x from here cannot be equal negative 4, and we have it, negative 4. Okay, all right. Next one, question number 6. it says the graph the function for graph the function for the range. Now for the range, in this case it's giving you range. Range is going to be from negative infinity to 1 and 1 to positive infinity. Remember, range is our y. So when we have domain, domain is our x and range is our y. So what does that mean? That means our value of x, let's say if this is my 1 over x, so range cannot be 1. What we are moving up by 1 right here. This is our y is equal 1. And the graph will look like this. How on the graph it will look at algebraically, this graph will look like 1 over x and plus 1. Look at the difference for this one and for this one. So x plus 4, now in number 5, x plus 4, it's a change of x, which means it's going x is equal, cannot be equal negative 4. But in number 6, 1 over x plus this 1, it's a change of y. Okay? Just so you know. Therefore, this is 1. And this graph is x is equal 1. I mean, y is equal 1. Okay? All right. Next. Question number 7. Match the rational function with appropriate description. Okay, we have rational function. Which function we call rational, by the way? The function that has x in denominator. Or fraction also. I can more generalize. Any fraction, it can be rational as long as there is x. Let's say 3 over 5 is not rational. But x over 5 is rational. 5 over x is rational. So x plus 5 and here x minus 2. Okay, so what we can say? Do we have here vertical shift or a shift of x? Remember looking at this example, number 5. Clean this. For number 5, we have here, this is a shift of x, right? Because we ended up with, here it is, we ended up with our vertical line x is equal negative 4. Okay? Which means here we have x plus 5. That means this is a shift of 5, correct? And that's a vertical asymptote. So which means here we're gonna put down the vertical asymptote is x is equal negative 5. Because the graph will have negative, the asymptote negative 5, like here. Okay? All right. Question number 8. Question number 8. So how graph will look, let's say when it doesn't have any asymptote, when it doesn't have any breaks. Obviously, when in denominator we have addition. For example, if I take f of x is equal 1 over x squared plus 2. Yes? This one doesn't have any break. We don't have any asymptote. Why? Because we have plus 2. Even if you take x is equal, first of all, no number squared, it's going to be 2, right? Which means x squared plus 2, let's say, cannot be equal 0, right? X squared cannot be equal negative 2. And indeed, as a real number, a square of any number never can give you negative 2. It has to be positive 2, which means this cannot be valid, which means x can be anything. So if in denominator you have all pluses, there is no minus. If it's minus, that's a different story. But if you have all pluses in denominator, then the graph does not have any vertical asymptote because it doesn't have any interruption. Question number 9. So we have the following graph. So one graph it goes like this. Let me see. The other graph is coming like this. So these are all parts of one and same graph. Which means this one also, let me do it better. Okay. So, we need to identify vertical asymptotes. So, if this is, let's see, negative 4 here, let's say this is negative 4, this is positive 4, which means this will be x is equal negative 4, this one x is equal positive 4. Then what is going to happen here? Our two vertical asymptotes are vertical asymptotes. X is equal negative 4 and x is equal positive 4. Okay? Now we need to identify horizontal asymptote. If this is negative 1, let's say, so this is going to be x is equal, y is equal, okay, I'm sorry, y is equal negative 1. So the horizontal asymptote is going to be y is equal negative 1. And lastly, let's look into domain. So what do we have as a domain? What value do we have here? So one piece, let me take this one. So one piece till negative 4, from negative infinity to negative 4, and then from negative 4 to positive 4, and then from positive 4 to positive infinity. Yes? Okay. So domain is going to be from negative infinity to negative 4, and then from negative 4 to positive 4, and from 4 to positive infinity. And that's all. Question number 10. So we have a graph. So let's say, what do we have here? Let's assume this is 6, negative 6, this is negative 8. So the graph comes here and drop here, and then again goes up and go like that. This is how look our graph. So let's see what we are going, how we are going to explore, what we are going to do. First of all, do we have vertical asymptote? No. The one more time, vertical asymptote, let's say we have here. This one would be vertical asymptote if graph is running to here and graphing running to this asymptote. So this one would be vertical asymptote, right? The graph is running to that asymptote. Okay. Now in this case, we don't have any vertical line where graph would run to. At this point, no vertical asymptote. VA, vertical asymptote. B, horizontal asymptote. Horizontal asymptote, on the other hand, we have it. So let me move a little bit higher. Let's assume instead of negative 6, we have negative 5. So negative 5. So horizontal asymptote, it's going to be y is equal negative 5. This is going to be your horizontal asymptote. Next, there is no any oblique asymptote. Oblique asymptote when it's running under in some angle. Okay, we don't have such thing. Like let's say graph is going like this and it's going like this, let's say horizontal at oblique asymptote. Okay, and lastly, the domain. Do we have here any interruption? No, we don't have any interruption, which means domain is going to be from negative infinity to positive infinity. Number 11. So what do we have? We have problem where it says x varies directly as y and x is equal 16. Okay, when y is equal 2. And find x. How much is x when y is equal? How much is 9? So because it's from the very beginning, it says directly proportional. Okay, so we need to find, we are going to use, let me see, we are going to use formula x is equal k times y, where k is a variation constant. K is a variation constant. So what we are going to do from here, we are going to find variation constant. So x is equal 16 equal variation constant times y is equal 2. Okay, so from here k is going to be equal, let me see, times 2. So from here k is going to be equal, divided by 2, dividing by 2, this 2 is gone with this 2, here is 1, here is 8, and our k is going to be equal 8, variation constant. Okay, so now following the same this formula, it says how much will be x is if y is equal 9. All right, so we know that y is equal 9, and we found out k is equal 8. So we find out how much x will be. And at this point, x gonna be equal 72. So how did I find this? Again, k times y. Y is given here 9, and k is is given here 8. So we got variation 72. Okay, next one. Question number 12. Suppose J varies jointly with G and V. Okay, J is equal to when G is equal 6 and V is equal 3. Find G. Now this time we need to find J when G is equal 10 and V is equal 11. So one more time. Suppose that J varies jointly with G and V. J is equal 2 when G is equal 6 and V is equal 3. How much will be J when G is equal 10 and V is equal 11? So what means jointly, varies jointly? We just did example of directly, varies directly proportional. But if there is directly proportional, that means there is inversely proportional also, yes? So, but in this case, it depends directly and jointly because we have and G and V. So formula in this case, J is going to be equal variation constant or constant of variation times G and then times V. Okay, we have J, we have K at the G, we have V. Can we find K? Yes, we can. So let's plug. J is equal to this is K, G is equal 6, V is equal 3. Okay, so K is equal, so to find K, what do we have to do? I'm going to divide by 18 because 6 times 3 is 18 already, right? I don't put twice. So 18, this 6 times 3, 18, with this 18, this in 2 over 18, it's 1 and 9. So we get K is equal 1 over 9. Okay, so from here, this J that we are interested to know, it's going to be equal, plugging K, which is 1 over 9, and then times 10, G is equal 10. That's what I'm talking about. Okay, times 10 and times 11. Okay, and from here j is equal 110 over 9. Okay, question number 13. If z varies inversely as w, so now we are looking into inverse, meaning the more is one variable, the same proportionally less inversely it will decrease the other variable. So let's see. If z varies inversely as w and z is equal 15, then w is equal 4. Okay, we need to find z when w is equal 10. Okay, how we are going to work this out? So for inversely proportional formula, z is equal k over w. This is inverse. You see that k, z and w, they are inversely proportional, correct? The more z is, the less w is. Okay, so we have z is 15, w is 4. We can find the constant, variation constant, right? So let's write down z is 15. W is 4. So k from here is equal, how much it will be? 15 times 4. So k is equal 60. Okay, now for the one we are interested, for this z we are interested, what I'm going to do? So z is equal k is 60 divided by w, which is 10. So, and it's going to be equal 6. That's all. So z, when w is equal 10, z is equal 6. Question number 14. Suppose r varies directly as the square of m. Okay, and inversely as x, as s. Okay, we have here mixture. Suppose r varies directly as square of m. Okay, so formula here will be r varies directly as square of m. Okay, directly square of them, and inversely as s. There we go, inversely as s. Okay, so what do we have? If r is equal 10, m is equal 9, then when r is equal 10, when m is equal 9, and s is equal 9. Okay, the question is, find r where m is 36, s is 9. Find r when m is 36 and s is 9. M is 36 and s is equal 9. Okay, so in the formula we have r, we have m, we have s. Here we have, right? So we can find k. So what we're gonna do? R is equal k times m squared over s. So bringing to common denominator this equation, common denominator is s, divide s multiply by s. I drop this and I get S R is equal km squared. I am interested in k, right? We need to find coefficient, constant of variation. Constant of variation, this is our variable. That's what we need to find. Therefore, I'm going to divide by m squared, because I need k, and divide here by m squared. And practically, my k is equal, this is gone with this, my k is equal S R over m squared. All right. So let's see. K is equal, let me plug. S is 9, R is 10, S is 9, 9 and 9, we get 10. K is equal 10. All right, now we need to find this R, yes, given this. So R is equal, I'm using this formula, so R is equal, K is 10, M squared, wait a minute, I didn't square it here, I apologize. I just noticed it's going to be 81. So which means here will be 9 if I reduce. Yes? Okay. So it's going to be 10 over 9. So we are getting 10 over 9 here. And then that's our k. And then we have m squared divided by s. So m squared, it's going to be 36 times 36. And dividing by 9. Okay, so this 36 with this 9, it's going to be 1 and 4. This one, 1 and 4. 4 times 4 is 16, and times 10 is 160. And here we have. Okay? Number 15. So, if z varies inversely as w, and z is given, and w is given, so z is varies inversely as w, so z is equal k over w because it varies inversely. So what do we have? Our z is equal 8, w is equal 3. Okay, z is equal 8 when w is equal 3. Now we need to find z when w is equal 6. Okay, again, so what do I have? Z is equal k over w. So from here, my k is equal z times w. Okay, so k is equal, z is 8, w is 3, I'm getting 24. And then I'm plugging all this information to z is equal k over w. So our k is 24 and w is 6. We are getting 4. So z is equal 4 in this case. Question number 16. So we have a graph we need to identify if this graph, the function 1 to 1 or not. How we are going to identify if this is 1 on 1 or not. So we are going to use horizontal line. Let's assume I take this and provide horizontal line here. Either here or provide horizontal line here. You can provide as many horizontal lines as you want. But so most importantly, you are watching if the same horizontal line is crossed by graph more than once, which it's not in this case. Look here. This is only once, this horizontal line. This horizontal line also once. Then we have 1 to 1, okay, function. We have 1 to 1 function. Number 17. Okay, we have the following graph. Is this 1 to 1 function? Absolutely not. You know why? Because if I provide horizontal line, it's crossing at this point and this point. Therefore, it's not 1 to 1. Because x value corresponds to every y value and each y value corresponds to every x value. No, not because of that. So this is not a 1 to 1 function because the horizontal line is crossing more than one point. Okay? Question number 18. So the graph of function is this. Okay? This is graph of function. Okay, this is our x, this is our y. All right. Is this a 1 on 1? 1 to 1? Absolutely yes, because see, providing a horizontal line and crossing only in one spot, right here. Okay, so it is 1 to 1. (19) Determine whether the function is 1 to 1. Now algebraically, this all was by graphing. Now we are going to identify algebraically. F of x is equal 3x cubed minus 8. Here is the thing. If we have this highest degree, if we have a degree is odd, that's mean every x gonna have only one y, right? If let's say x is 1, positive 1, then the 1 to power 3 is 1. Because we have here 3, right? If I have negative 1 to power 3, it's getting negative 1, right? So as you can see, every x, negative 1 has negative 1, positive 1 times has positive 1. Okay? So because it's a cube, so we don't have several choices. It's only degree 2 and 4 and 6 and 8 can, the positive and negative will give me one positive because its degree is even. Therefore, when degree is odd, then we have yes 1 on to 1. And the last one, we have y is equal 30 x plus 5 squared minus 6. Okay, so here we have x to power 2, right? So x squared. Because we have x squared, so 2x's will have 1y. Yes? Negative 2 squared 4, positive 2 squared also 4. That at this point, this is not and 1 to 1. All right, I'm done. Thank you for watching. See you in next video.